Welcome back. We're going to start a new chapter. This new chapter is on rational numbers. It includes decimals and fractions. We're going to use the same rules as we did for integers. So we're on lesson 4-1, terminating and repeating decimals. There's some vocab we need to talk about. The decimal form of a fraction is called a repeating decimal. Now, not all decimals you'll see repeat, but ones that do can be represented using bar notation. And I'm sure you may have heard about a repeating bar. So the bar notation is drawn only over the digits that repeat. So in 0.333, you see the three dots afterwards. That means it keeps going on, but the pattern is the 3 repeats. So I would put the bar over one of the 3's, and that means the next digit would be a 3, the next digit would be a 3, and so on. In the second case, the 1 doesn't repeat, but the 1, 2 do. So it would be 0.12, and I would put a bar over the 1 and the 2, because that's what keeps on repeating. In question number 11, or not number 11, in 11.385858858, you'll notice that the 3 does not repeat, so I keep that digit, 11.3, and then the 85 is the one that keeps repeating, so the bar only goes over the 8 and the 5, not the 3, because that would be 385, 385. If the repeating digit is a 0, the decimal is a terminating decimal. You may have heard the word terminating or terminate. It means to stop. I know in the movie The Terminator, it's a guy that tries to stop the human race. The terminating decimal, 0.25 with a bar over it. The 0 means the 0 repeats, but it's typically written 0.25 because the 0 means that it terminates. So express each repeating decimal using bar notation. So for number 1, we're looking at what digit repeats. So this is the time where you may want to pause me, come back, see if you have these 3 completed, and then we can continue on. So for number 1, it's 0.1 with a bar over it because the 1 repeats. And number 2, 0.61 with a bar only over the 1 because the 6 doesn't repeat. And in number 3, 0.61, and make sure the bar goes over the 6 and the 1. The second part, converting fractions into decimals. Any fraction can be expressed as a decimal by dividing the numerator by the denominator. So I remember a teacher of mine a long time ago used to sing the song, the top goes in the box, the top goes in the box. To change a fraction to a decimal, the top goes in the box. So the top number, the numerator, is going to go inside of the box when you divide it. So the numerator really is the dividend. So what you're going to do, we're going to use long division to do this. The top number, the 3, is going to go inside the box. That means the 8 goes on the outside. We're going to add the decimal and a couple zeros. The decimal we bring straight up. Now if you're confused and you put the 8 inside and the 3 on the outside, your answer is going to be 2 point something. We know that 3/8 is less than 1 whole. So if we reversed it, we'd get 2 point something, which doesn't make sense because we know it's not less than 1 whole. Or not more than 1 whole, sorry. So the 8 goes into the 3 0 times. 8 into 30 is 3 times. That's 24. Subtract, we bring the 0 down. And you notice if we stay nice and neat, this becomes a lot easier. So I'm looking for 8 into 60 is 7. That's 56. I'm going to add another 0 here and bring that down. So 8 into 40 is 5, and that works out to be a terminating decimal. So 3/8 is the same as 0.375. Number 2, negative 1 over 40. So I know that this is going to be a negative answer. I'm worried about just converting 1/40 into a decimal. So the top number goes in the box, so I put the 1 inside. The 40 goes on the outside. I'm going to add a decimal and a couple zeros, and I bring that decimal up. I'm going to put the negative here. So that's a 0. 40 goes into 10, still 0 times. 40 into 100 is twice. That's 80. I subtract and get a 20. I'm going to add one more 0 here and bring that down. 40 into 200 is 5, and that works out to be 200, so that terminates. So negative 1/40th is the same as negative 0.025. Number 3 and 4, I'm going to leave for a second so you can try those on your own. 5 and 6 are a little different though, so I want to make sure that we get a chance to do those. I'm going to bring this back a little bit. Number 5, notice that's a big number, so when I divide that, 24,158, sorry about that, 6 divided into 24,158. My answer should be big because it's a whole number. So 6 into 24 is 4. Bring the 1 down. That's a 0. Notice I'm trying to stay nice and neat. Put the numbers above where they go. Bring the 5 down. That's 2. That's 12. I subtract. I bring the 8 down. 6 into 38 is 6 times. That's 36. I subtract, I get a 2. I'm going to add another 0 here and bring that down. So my decimal is going to be here because that's where I added that 0. Sorry. So I bring it up and I'm going to continue this on. So 6 into 20 is 3 times. That's 18. And you're going to notice that when I start subtracting this, I keep getting 2 for the answer. So this means the 3 repeats. So 24,158 over 6 is 4,026.3 repeating. Question number 6. The 8 I'm going to leave by itself for a second, and I'm going to change 1/3 into a decimal. So 1 goes inside, 3 goes on the outside, add a decimal and 2 zeros. Bring the decimal up. 3 goes into 10 3 times. That's 9, and I subtract. And again, you're going to notice that this 3 repeats. So it's not 0.3 repeating because I have that whole number of an 8. It's 8.3 repeating. I put that 8 in front for the whole number, so it's 8.3 repeating. So question number 3 and 4 we did not do, so I'd like you to try those and bring them to class, and we're going to go over them together. We're going to go on to the next page here. Talk a little bit more about decimals. We can also convert decimals into fractions. So every terminating decimal can be written as a fraction of the denominator of 10, 100, 1,000, or a power of 10, which I'll show you how to decide what you use. So you're going to use the place value of the last digit as the denominator. So in this case, we have a guppy is 0.25. That 5 is in the hundredths place, so that means it's 25 over 100. So however you say it is how you write it. So this would be 25 over 100. And then we're going to reduce that. So 25 over 100 reduces to 1/4. There's another way to think about it. However many places you need to move the decimal to make it a whole number is how many zeros you add. So for angelfish, it's 0.4. If I move this over once, that makes it the whole number 4. So I would do 4, and I have 1 0, so that's a 10. So this would be 4/10, and reduce that would be 2 over 5. So however you say it is how you write it. Goldfish is 15 hundredths, so 15 over 100. When I reduce that by 5, I get 3/20ths. And the last one, the molly, is 0.2, which is 2/10, which reduces to 1/5. So you can write any decimal as a fraction by either knowing how to properly say the number with the last digit, or move the decimal over until it's a whole number and all the digits are used and adding that many zeros in the denominator.